Hey everybody, we are back. Sorry for the little longer break. We had some more fun with Teams and Skype and all the fun internet things that happened. But guess what? We have Ryan Nowak on the phone right now, on a Teams call actually, so we can learn about how to scale our Blazor applications on Azure. How's it going, Ryan?
Hey, Javier, good to hear from you. Glad to finally be on the call and be able to show my content. This is
I
great.
I know we've had a lot of fun today, right? Trying to get all this going.
Well, it's good when your conference begins with like a snow day,
That's right.
and everybody being buried under mountains of snow. So this has been exciting.
Great. Well, so we make the most of your session. Let's get started. Take it away.
Okay, great. I assume you can see? All right, let's get started. So Javier already introduced me. My name's Ryan Nowak. You can find me on Twitter if you want. And today we're going to be talking about scaling Blazor server, and in particular SignalR and the Azure SignalR service, and why these kinds of things are important for your scale up and scale out. So about me, I'm a developer on the .NET and ASP.NET team at Microsoft. I was engineer number 2 on Blazor, so I came into the project at the very, very early days, before we had things like server-side Blazor, back when things were looking pretty different. You'll be able to find all my presentation materials, demos, slides, etc. on my GitHub at that repository. Shortly after the presentation is done, I will push the latest version. And about some of the things that I work on, I've been part of the .NET Core project since the beginning, since before we called it .NET Core. And I pretty much worked on just about everything within the ASP.NET Core side of .NET Core. So MVC, Razor, now Blazor, lots of different stuff. So if you use .NET Core, you use ASP.NET Core, chances are we've crossed paths in one way or another. So before we can really talk about scaling Blazor server and scaling up Blazor server with the Azure SignalR service, we need to get a sense of what is Blazor server, what is a Blazor server app, and how it sort of works. So we've probably seen a lot of Blazor WebAssembly demos today. What makes Blazor server unique, probably among all of the different web frameworks and UI frameworks out there in the world, is the way that Blazor server is implemented and the way it works. So you've got ASP.NET Core running on the server with your Razor components running .NET inside your application, and you've got users out there with a browser and a browser DOM that's being manipulated by the Blazor application. And you can sort of think about those yellow arrows in the middle as like events coming back from the browser and DOM updates going to the browser. And there's just this never-ending cycle of the browser saying like, hey, I got some information for you to process, and the server saying, okay, here's how to change the UI in response to that. And there's a few more things that fly back and forth, but basically that's the gist of it. And you can think about that thing in the middle, that's SignalR, with the poor contrast that you can probably barely make out. SignalR is the communication mechanism between Blazor running on the server and the piece of Blazor that runs inside your browser in a server-side Blazor app. And that's really going to be our focus today. So I'm going to jump out of slides, and we're going to jump into a quick demo. I've got a little app here, and I'll go ahead and run that up. And I'm just going to .NET run this app, and it's going to fire up. Meanwhile, I'll bring it up in a browser here. And it's just running on port 5000. We're still waiting. We're still waiting. I don't know why it's slow. I think it's only slow when you're demoing something. There we go. All right, let's refresh this. And here we go. And we're going to talk about this page later, so I'm just going to hide that real quick. And I want to focus your attention to this sort of UI that I have here, as well as some of the things that are going to be going on down in the browser tools. So you've probably seen a lot of counter pages before if you've watched a lot of Blazor demos in the past. And mine is special because it's got this little very exciting banner here. And when I click this button, you can see that not only is the count going to go up, this banner is going to toggle back and forth between bold and not bold. And this is going to be our little sample to talk through for the purposes of demonstrating how Blazor works. So one of the things that's really neat about Chrome, I can come over here and I can highlight this thing, and Chrome will give me a nice visualization. I think other browsers do this too, by the way. But Chrome can give me a nice visualization of what changes when I click the button. So if you look down here in the gutter here in the sort of elements view, or the view of what's in the DOM, if I click, you're going to see some pink flashes. And you're going to see that I can prove that my my style tag is collapsing and then going to say font weight bold. Yeah, I know, boo hiss, inline style, you know, throw everything at me. You can also see that your current count here, this little number, we're just updating that little span of text, right? And that's the only things that are changing, is these two things changing. And you get a key insight about Blazor about from this demo, and by the way, this is true of both Blazor Server and Blazor WebAssembly, is that Blazor does in general the smallest DOM update that's reasonably possible. So we're literally just updating this one attribute and this one span of text. If Blazor were throwing away the whole page and kind of just pasting over it with a whole new HTML document, you would see the whole thing light up pink when I click this button. And it's really just that one part. So the other thing that we're going to learn from this app is here in the network tab. And if I refresh this page, we'll be able to capture the network traffic, and I can click on this WebSocket here, which is probably what we're going to spend the bulk of the time talking about today. And if I look at this WebSocket and Chrome shows me kind of what's going on, I can see there's a bunch of different messages that are coming through this WebSocket. So you see protocol Blazor pack that tells us we're doing Blazor. And then there's a whole bunch of binary messages going back and forth here of varying sizes. And every time I click my button, you'll see that there's a few more messages that get exchanged here. So you got a 291, a 229, a 27. I'll click the button again. I got a 291, a 211, and a 27. So every time I click this button, you can see those messages are flying over the internet. And ultimately, that communication with the server, that communication over this WebSocket right here, is the thing that's kind of making our application run. Let me jump back to my slides real quick. So we've seen sort of how Blazor Server works. We're updating the DOM, we're updating the UI, and we're sending messages over that WebSocket connection. Looking at my code, this is the code that goes along with this demo. I've got this fancy span component, which is a component I wrote. It's pretty useful. I should probably publish it. And it just toggles back and forth between bold and not bold. Other than that, it's a normal span. I've also got an event handler hooked up to my button so that I can call this increment count button, increment count method every time that button is clicked. And I'm just going to update the current count variable, which will trigger an update to both my fancy span style and to the current count display. So how does Blazor update UI? Well, on a conceptual level, you write components. Components respond to events. And then when components respond to events, they do what we call is a render. A render means basically that this code that's right here that represents all that HTML runs. And the output of render is basically a list of, like, what are the HTML elements? What are the attributes? What are the text? What are all the things that need to appear in that document or need to exist in that document? You can think about that as being what happens when you do a render. The other thing that we learn about a render is that a render can trigger updates to other components. So in this case, like, we need to update both the counter page, which is this page, as well as our fancy span. And the way that that actually works is because the parameter value of our fancy span has changed, because the current count has changed, so is bold is going to go from true to false, and back again. We know that we need to re-render fancy span. And those are some of the things that the Blazor runtime does for us. So in this case, when we click the button, well, what do we need to update? Ultimately, when we do the render pass of the counter component, we see that that little span of text where current count lives needs to update because the frame that represents that piece of text is going to be different. Likewise, we see that fancy span will need to re-render itself because we see that the parameter value that we're passing to fancy span is going to be different every time we update. That's kind of the essence of how Blazor works when you do rendering. So what happens next? Well, the components produce their frames, which represent all the things that show up on the page, as well as represent the other components that they contain. The runtime takes these frame outputs from the components, and it processes each component that produced an output. And for each component, it stores the previous output, and it can compare the current output to the previous output and produce a really efficient diff. And you can think about that diff as sort of like an assembly language, like a low-level set of instructions to the computer or to the browser about how do you get from the current state to the future state. Then the runtime sends that diff back to the browser, and that's what's going to go over that WebSocket connection. So before we talk a little bit more about SignalR, I'm just going to pull back the curtain another little step here. which is that if we highlight one of these messages, you can see down at the bottom, and it's kind of small and tucked away, you can see down at the bottom what was in that message. So this 291 byte, you can see it has an up arrow. This was sent from the client to the server, which is what the up arrow means. And you can see that it's got some JSON in it. That's kind of what this is. It is a binary message, but it contains some JSON. And if you've done some DOM programming or some browser programming before looking at Blazor, you'll probably recognize this as all the data that you get when you click a button in a browser-based application. Like, we literally serialize the event data to the server as JSON so that you can get it on the server. So if you've used event handlers in Blazor and you've seen the same kinds of data that you get in the browser, that's how that works. We send it from the client to the server. We also know that for the typical case, it's not that big. 291 bytes is not a very big message. It's not a big amount of data to send back and forth every time you click a button. Then the response to that is this thing called a render batch. Now, there's a bunch of stuff here that's not going to show up in any sort of readable way, and that's because of that low-level instruction format that I talked about, that diff format. But the one thing that I will call out is you can see something here that kind of looks right, kind of looks like text. It says style dot font weight bold. There's my cool inline CSS. So you can see sort of the makings of what is going to show up in the UI. You can also see that 8 is here. This is probably what toggle the current count or something like that at some point. So you can see that roughly it's a binary format. It's not intended to be human readable, but it roughly represents what you see in the UI. The Blazor code in the browser is what's going to decode that and understand how to send it back and forth. So what is SignalR, and what is SignalR's role in all of this? Well, SignalR is an application framework that's part of ASP.NET, and it's useful for doing two-way real-time communication. So you think about your typical browser-based application, pre-Blazor, of course, in the old days. You would go to the server, you would load the page, you would get the HTML, and that was the end of the story. Well, that's because HTTP is a two-way request-based system where you get a request and a response. There's a lot of user experiences that we use today that are like more dynamic and more proactive and more real-time in that. We tend to use the word real-time to describe something that's not request-response, at least within the bounds of the web. So SignalR is an application framework that's useful on its own for building those kinds of experiences that require two-way communication between a browser and a server, and require that kind of communication to be done in real time. SignalR is an RPC-based framework, so it's like you define a hub on the server, which is pretty similar to defining an ASP.NET Core controller, and then the client can call methods on the server. Likewise, the server can call methods on the client. SignalR supports a variety of different communication patterns. You can have one-to-one, you can have many, you can have different groups and broadcasts, and it's really designed for all different kinds of communication paradigms that you might need to do when you're writing applications that are real-time or are event-driven. Likewise, you can do communication using SignalR from the client to the server and server to the client. And SignalR has a server implementation in .NET. There's one for older ASP.NET, and likewise there's one for ASP.NET Core. But there are clients in many languages. I think there's C++, there's JavaScript, there's a bunch of different clients that you can use. There's Java as well. There's a bunch of different clients that you can use to talk to SignalR on the server running in anything. And in addition to that, SignalR supports many transports. And what I mean by transports is like, well, how does the communication with the server actually take place? Because we said that HTTP is request response. And the answer is that there have been a bunch of different technologies that have existed for this over periods of time. So in the beginning, the way that these techniques were done was with something called long polling. Because long polling just relies on HTTP. It's a very primitive technology. And the way that long polling works is the client sends a request to the server and basically says, hey, server, tell me when the next thing happens. That's a way to allow the server to communicate with the client. So the client sends a request to the server that's just basically going to hang out until the server has something to say. So then the server has an event, it triggers a response, and then the client has to immediately start a new request to basically start waiting again for the next event. Upside of long polling, it can be supported on pretty much any browser because it's a very old technique and a very old technology. Just requires HTTP. Downside of long polling, well, low bandwidth and low sort of like high latency, because you might need to you need to send a new request before you can get a response again. If the server has a lot to say, it's probably not going to work very well. After long polling, there came along something called server-side events. Server-side events actually use the same request and response and allow the server to just stream out individual events. So the client creates an event source. This is a JavaScript API, which opens a request to the server, and then the server can trigger multiple events within the scope of the same request. So that's not really two-way. It's more of a one-way pipe. So if you're doing server-side events, you still want sort of a side channel for the client to be able to communicate with the server. So server-side events are somewhat new of a technology. It's been around for maybe 7 or 8 years, maybe slightly longer, but they don't really see a ton of usage in the wild because something better came along. Another thing that's better is WebSockets. So WebSockets basically just open a two-way pipe over HTTP. So the client makes a request to the server and says, hey, server, I'd like this to be a WebSocket. And then the server says, yeah, that's okay with me. And they open a WebSocket. And then they have a bidirectional pipe in which to communicate. And a WebSocket basically works like a TCP connection from the point of view of the code you write, where you don't really have to juggle the details of the protocol. You just send the messages back and forth. WebSockets are currently kind of the state of the art in terms of bidirectional client-server communication. And WebSockets are kind of like what you hope you're using if you're on server-side Blazor, or really what you hope you're using if you're using any of these technologies, because they're the most modern and the best. Some older versions of Windows or some older browsers may not support WebSockets, but other than that, there are fewer drawbacks compared to the other technologies. So those are some of the transports and some of the kinds of things that SignalR can do. SignalR basically provides you the same API and the same programming experience, regardless of which one of those underlying transports are using. So if you're programming to SignalR, you don't really care if your client is using server-sent events, or your client is using long polling, or your client is using WebSockets, because SignalR is kind of higher level than that and hides those details from you. Blazor uses SignalR down in its guts, which is why Blazor is able to work with long polling, or Blazor is able to work with WebSockets. And we don't really care about the details other than wanting the one with the best performance. So Azure SignalR service is an Azure service that exists to help scale up and scale out usage of SignalR in the cloud in Azure. Now, the reason why you might want Azure SignalR is that you might need to, say, have multiple apps that all communicate through the same sort of SignalR backplane. You might want to scale your usage of SignalR up to thousands of connections. You might want to have one IP address or one address that clients connect to, regardless of which instance of your backend they're talking to, and get a uniform experience. You might be deploying on App Service or one of the other environments in Azure where you don't get access to a ton of WebSockets. So you can basically think about Azure SignalR service as like your dedicated service to help scale up the SignalR part of your application and the WebSocket part of your application, independent of the rest of your application. You might not need too much processing power to actually serve a Blazor server app, but you might want to offload the WebSocket processing capability, either to reduce resources or to increase the number of connections that you can handle. And the SignalR service is here to help you with that. One of the really nice things about the SignalR service is that using it now, I think as of .NET Core 3, is just adds a NuGet package to your project. You don't actually have to write any code. So you don't have to do the dance where you say, like, well, I don't have this in my local environment, so I can't run it. I need to if-def this, and I need to switch my environment. Using the Azure SignalR service ends up being pretty transparent to your application. It just adds a NuGet package. So how to visualize this and how to think about the role of the SignalR service. You've got your ASP.NET Core app there. You're serving some pages, and you're doing server-side Blazor. And if you're not using the SignalR service, then all of your web traffic and all of your SignalR service is all going directly to your app. If you add the SignalR service, then your web traffic is going to your app. Your SignalR traffic is going to the Azure SignalR service, and it's sort of just getting bounced back to your app. That's that sort of grayish arrow in the middle there. Now, why would you care about this? Why do you actually care? The answer is in the size of the arrows. So imagine if you had like 1,000,000 clients, or like 100,000 clients, or 5,000 clients. Like, that's 5,000 connections to the Azure SignalR service in this one. If you're in the first example, that's 5,000 connections to your website as well. So that's a lot of resources that need to be allocated in your website to handle the details of processing the WebSocket connections. And that's a lot of connections, inbound and outbound, that your app itself needs to be able to make. What happens when you're using the Azure SignalR service is that those connections get multiplexed between Azure SignalR and yours. So Azure SignalR and your app will open a measly 5 connections between each other, and will multiplex the connection, all of the transport data over a very fast network connection between Azure SignalR and your app. So the result is your app basically does less work handling the WebSocket part. You can scale much higher in terms of number of connections you can have, because Azure SignalR service is purpose-built for that reason. Reduce load on your app, reduce number of connections you need, and it has a bunch of really nice features if you start talking about scaling out a Blazor server-side app. So one of the things that Blazor server-side needs is it needs what we call stickiness in web terms. When you do a request to a Blazor server-side app, it wants the WebSocket connection to be opened to the same server that served the HTML. Likewise, if you get disconnected, which would be unfortunate, but if you get disconnected from that WebSocket connection, Blazor has a reconnection feature. The browser client will try to reconnect and will try to put you back into the same state that you were in before. Well, since all your state lives on the server, what would happen if your reconnection went back to a different server? Your state wouldn't be there, so it wouldn't work. So when you actually scale out Blazor Server by deploying multiple apps via app service or something like that, if you're using Azure SignalR service or anything else that provides a sort of sticky sessions for WebSockets, then you don't really have to think about these kinds of server affinity problems. They're just done for you. The server that serves your HTML is going to serve your WebSocket because it's going to be sent there by the SignalR service. And if you get disconnected, the server that you reconnect back to is going to be the same one, so your state should hopefully still be there. So in that way, the SignalR service is pretty useful for scaling out your app. What it looks like for you to hook up Azure SignalR is if you're publishing to Azure and you're like ready to go, you'll probably see this warning down in the bottom here if you haven't configured Azure SignalR. Now, if you want to, you can go ahead and publish, like nothing's going to stop you from doing that. But what's in that sort of green box at the bottom, that's not in the Visual Studio UI, by the way. I added that so you could see it. You get a warning that you're not using SignalR. And what this is Visual Studio is able to detect basically that it's a Blazor server app, and it's able to say, hey, you really might want to think about this. In particular, if you're deploying to app service and you're not using Azure SignalR, you really might want to think about that. The next thing, if you click Add, it's going to take you here, and it's going to give you choices about different dependencies. Then you pick the Azure SignalR service from this list, and it'll do that. So some of the considerations for scaling up Blazor Server and scaling up the number of connections that you can take. First of all, Blazor Server needs stickiness. Azure SignalR can give you that. Blazor Server needs a WebSocket or another SignalR mechanism connection per user. What we find with app service or other Azure services or other cloud-based services in general is they tend to underprovide on the number of WebSockets you can handle in an app. So you tend to have, if you provision sort of standard app on app service, sort of reasonable amount of capacity to serve web traffic, but a pretty low amount of capacity to be able to serve WebSocket traffic. Azure SignalR service is a dedicated service to offload that WebSocket traffic or that other SignalR traffic so that your app can do app stuff. And it means that you could probably get away with a smaller number of app deployments if you're using Azure SignalR service because you're offloading the WebSockets to something purpose-built for that. The Azure, if you look down at the bottom in the details, Azure does document what the limits are for WebSockets on various app service SKUs or various other environments. The limits that they say that they have for these things are kind of like best effort. Like they'll give you at least that. You might find that in some cases you're able to actually do more connections than they say you're able to do. I was doing some testing on this earlier today and found that I could exceed the number of connections that they said I had available. But what that really means is that it's not reliable. They're not guaranteeing you that you'll always be able to make that number of connections. It's kind of a, well, if they're available, you can do it, and if not, it won't work. I also found that when I was doing that kind of testing, comparing the amount of load on my app with and without the Azure SignalR service for same number of connections, there was significantly more load on my app when I was not using the SignalR service. So it's definitely a factor to consider if you're planning how much capacity you'll need to put Blazor Server in production. Another word on sort of planning Blazor Server capacity and thinking about how your application might scale. These are the results of an experiment that I did recently. And you should think about these, don't think about these numbers as necessarily applying to your app. Think about these numbers as sort of like, this is where the framework puts you. Everything that your app adds on top of this is kind of yours to think about and yours to plan for. So I did this experiment by basically setting up a couple of VMs and opening a bunch of connections in between them. And I only went up to about 5,000 in this case. What I find is that if you've got a very simple like template style of app, each connected client you have reserves about 86 kilobytes of server-side memory. So there's about 86 kilobytes of memory that you're going to have reserved for each client. Again, that's what the framework requires of you. So as you're thinking about capacity and scaling and size of your Blazor app, think about the number of clients you need to support. How many clients and how many users do you expect to have at a time? What's the max? What's the average? And also think about what kind of data are you going to manipulate in your app? What kind of things are going to be in memory? What kind of things are you going to access in the app? Does everybody need to load 1 megabyte of data into a data table? Plan for that. Add that to that 86 kilobyte number. Your usage is going to vary pretty dramatically on the needs of the application. The other sort of note here is the things to think about in terms of planning scale. For the most part, we think that for Blazor server-side apps, the things that matter most are like the amount of memory you have available to you. You're probably more likely to run out of memory than you are to run out of CPU or run out of some other resource other than WebSockets. So that's probably the first thing that you should think about when you're planning your capacity. And again, this is based on a framework, what the framework does, based on creating a really simple app and then sort of test driving it. The way that this is tested is we have a headless client for the Blazor protocol that we use for security testing and a bunch of reliability testing that the team developed. And I basically use that to just open a bunch of connections and test drive an app. This is what the memory usage looks like, all of these data points after triggering a garbage collection. And that's with each of these clients doing some work. So each of these clients is going to that counter page and clicking the counter button every half second or so. So it's not 5,000 connections sitting idle, it's 5,000 connections actually doing something in the app. So let's talk about how we can sort of visualize connections and how we can look at these sort of things. I've got another demo running here. And I've actually deployed, in this case, I've actually deployed this demo to the cloud and deployed it to Azure App Service. So I'm going to go ahead and I'm going to start running this. And we will, I'm going to get to the right tab here. I'm going to go ahead and deploy this and run my script. And then we can talk about what it's doing while that's running. Okay, and I don't have my scripts folder here. So I'm just going to go ahead and run this locally then, since I appear to be missing a folder here. So I'm going to go back to this tab, and I'll go ahead and start running my demo app. And I'm going to talk about this connections page that I sort of skipped over again here. And in the meantime, I'm going to start running something. So I'm .NET run-p, my demo client, and the arguments I'm going to pass to it. Run this with localhost 5000, and let's go up to 500 connections because Teams seems to be putting a lot of effort on my machine. So this is going to start opening connections in a few seconds here, and it's going to start sort of chugging away with this local web server. So if I come back to my app running here and I refresh, I'm going to go to home, and this is going to start updating. I have a background timer on this page, and it's going to start updating. So this component in this page here is just basically running a little timer loop. And every little bit, it's going to track the latency of its connection to the server, and it's going to track my number of active connections. And you can see that sort of going there. This thing's updating about every 3 seconds or so. So 500 connections, not super exciting. Let's try a higher number. Let's try going to 5,000 and see if we can do it. And again, this is just running locally on my machine for now. I had an Azure demo set up, seem to have lost it. So I'm not gonna waste your time trying to track down what happened to those files. In the meantime, let's look at the code of this, and I'll sort of show you what's going on here so we can understand this a little bit better. So we're just going to bring up VS Code over here. So again, see we're chugging away here and getting more and more connections. You can see the latency here is still pretty low because I'm on the same machine. I'm running locally. And if I come over here to VS Code, hopefully this will have loaded in and we can look at some of the stuff. It is not open the right. So it's not in the right folder. So we can talk about what's going on in this app and how this kind of works. I think people might appreciate a little bit seeing sort of how this is put together and how I'm measuring these things, because you might be interested in doing some of these things on your own. So what's going on in my index page is I have got a timer running here. The most important thing that I will point out to anybody, anytime I say the word timer and Blazor in the same sentence, implement iDisposable, please. So this component creates a timer. It also is disposable so that when it goes away, it will stop the timer. What I'm doing inside of my timer loop is I'm making a JS interop call, and I'm just timing it. So I've got my stopwatch here. I'm starting a new one. I'm making a JS interop call to this ping function, and I'm capturing the number of elapsed milliseconds. If we flip over to my page where this is my host page, this is all it takes. This is all it takes to measure your latency to your server. So this page is just going to, in real time, every couple of seconds, update and show you what your latency is. As far as measuring the number of active connections and being able to track the active connections, we have this feature called the circuit handler. Circuit handler lets you attach to some events, so you can be notified when there's a connection coming up and a connection going down. And I'm just keeping track of basically what are all the circuit IDs that I have available. You should think of a circuit, it's a term that I made up actually. A circuit is a browser tab. It's the equivalent of a browser tab in Blazor server-side terms. The reason why we call it circuit and not connection is that Blazor has reconnection. So a circuit can span multiple connections. That's why we use the term for it. So I'm just keeping track of how many circuits I have open via this little concurrent dictionary here. And I have a connection tracker service that is just keeping track of those things that gets incremented and decremented. And then in my index page, this loop is going to run, I think I said every 3 seconds. I'm going to capture the latency. I'm going to capture the number of active connections. I'm going to say status changed. I'm going to set what time I updated it. And that's the whole thing that powers, that's the whole thing that's powering this UI. That's really all it takes to sort of see what's going on with your scalability. You can see now that we've got upwards of 1,000 or so. This is starting to chug down and starting to be a little bit slow on my poor little Mac that's trying to do Teams and Skype and this at the same time. Anecdotally, when I've measured this, what I typically find is that the client will end up using more resources than the server. So if you do this, if you do any sort of testing of load, you can sort of look at what we've done and crib from that. But my advice would be to try and test as real of a situation as you might actually encounter, because you might find and check yourself, because you might find that your load testing setup actually requires more resources than the server, which is the case with mine right here. So with that, I think I'm out of sort of stuff to say. Hopefully this has been useful and you've enjoyed hearing about server-side Blazor and scaling and Azure SignalR and all the aspects of deploying and scaling. So I'm going to turn it back over to Javier.
Hey, Ryan, thank you so much. Yeah, this is really great. Quick note, everybody, we're actually, for .NET Conf, we use SignalR Service behind the scenes. It's a great platform where it can scale up to all you viewers out there, and it's great. So thank you so much, Ryan and team, for all the work that you have.